Hello, my name is Rashid. My surname is Utkurov, and today we're going to talk about uh, the introduction to continuous random variables. Yep, continuous variable that can take any value in interval. This means value is not fixed or continued in the whole number day. For example, indeed, the time needed to finish an exam is a continuous variable. It can be 45 minutes, 40.5 minutes, or 40.53 minutes. Other examples include distance, temperature, and height. These variables are too important because we use it in business economics because many real-life processes are continuous. Continuous probability distributions used for continuous variables. Probability equal to area under curve. Sorry. And example probability of temperature range describes how continuous probability distributions describes how probability are spread over continuous values. Unlike discrete variables, we don't calculate a probability at exact one point. Instead, probability is shown as an area on the curve. Just for an example, we can calculate the probability that temperature is between 20 and 25 degrees, not exactly 23, 22, or 21 degrees. Types of continuous distributions. There are several types of continuous probability distributions. The most important ones are uniform normal, exponential normal distributions. Each is used in different situations. The uniform distribution is used when all outcomes are equally likely. The normal distribution is used when the data is symmetric. That's, I think you got it. Uniform distribution. I'm so sorry. Uniform distribution concept. The distribution in I'm so sorry. In the uniform distribution, every value in interval has the same probability. This means is no more likely than another. The distribution is defined between a minimum value and maximum value in B. Outside interval, the probability is 0. For example, if we randomly choose a number between 0 and 10, every number has the same chance to be. Uniform distribution formula, as you can see. Here is the smallest possible value, A, wherein B is the largest possible value. This formula shows us that the height of the curve is constant for all values inside the interval. Priorities of uniform distribution. This means average of the minimum and maximum values. And this means the center of distributions exactly in the one middle. This variance depends on how wide the interval is. Wider interval means larger variance. For example, for values from 2 to 6, this means a 4, which is the center of interval. То есть середина, ortası. Uniform distribution example. Just let us consider uniform distribution from 2 to 6. The length of the interval is 4. The probability density is equal to 1 divided by 4, which is 0.25. This means of distribution is 4. The variance is approximately, if I'm not mistaken, 1.33. Yes. This example shows us how to easily work with uniform distributions. Next slide, expectation of continuous variable. The expected value is a continuous random variable is its mean. It shows average outcome in the long run, not in small. Variance show how much values differ from the mean. A small variance means values are closer to the mean. A large variance means a lot spread out. For example, the average waiting time in a bank is an expected value. I think that you got normal distribution features. The normal distribution is one of the most important distribution statistics. It has a bell-shaped curve. This distribution is symmetric, so the left side is the same as the right side. The mean, median, and the mode are equal. A common example of normal distribution is exam scores. Next one is the normal distribution priorities. The normal distribution has an infinity range, from a minus infinity to plus infinity. It's completely defined by two parameters, the mean and the standard deviation, if I'm not mistaken. Changing the mean shifts the curve left or right. Changing standard deviation changes how wide the curve is. For example, the height of the pupil often follow normal distribution. Standard normal distribution is a special case of the normal distribution. Its mean is 0. Standard deviation is 1. Any normal random variables can be converted into z-score. This allows to compare values from different distributions. For example, we can compare the test from different exams using z values. And the last one is exponential distribution. The exponential distribution is used to model waiting time. It describes the time between two events. It is commonly used in service systems such as bank or shops. For example, it can model time between customers arriving at the store. The mean is of exponential distribution equals to average waiting time. I think that you got what I said to you. This is finished. Thank you for your attention.